This video describes a few of the known biologic features of the amoeba Vampyrella latericia. Vampyrella was classified by Leidy as an aconcholinid sarcodine as early as 1879. Vampyrella was awarded its own genus and was placed under the kingdom Protozoa, a term now largely supplanted by the term protist. In 1885, Zopf classified Vampyrella as a cercozoan, a subclassification recently supported by Cavalier-Smith and Chow. However, at the present time, the exact classification of Vampyrella and its taxonomic relationships to other protists seem to remain somewhat uncertain. The Guide to Protozoa, published by the International Society of Protistologists, recognizes the earlier classification of Vampyrella as to genus, that is, Vampyrella Leidy, 1879, and as to family, that is, Vampyrellidae, Zopf, 1885, but considers Vampyrellidae to belong to the collection of amoebae which it terms amoebae of uncertain affinities. The following are some of the generally recognized features of amoebae of uncertain affinities. They are amoeboid eukaryotes. From the standpoint of evolution, they probably have arisen from flagellated protists. They are either unicellular or syncytial. They lack flagella in early trophic phases, and they lack cilia in early trophic phases. Here are two photomicrographs and a diagram depicting Vampyrella. Vampyrella has numerous fine, tapering, phylose pseudopodia. It has a distinct ectoplasm, which tends to be hyaline and is highly vacuolated. The endoplasm is finely granular, vacuolated, and typically colored red, orange, or pink. The nucleus is centrally located, ovoid, and pale gray in color. The appearance of Vampyrella varies, depending upon whether it is free-floating or moving on a surface, such as the surface of a glass slide. When it is floating freely, Vampyrella tends to resemble a heliozoan, for which it is easily mistaken. Its body is rounded up, and its pseudopodia radiate like numerous axopodia. However, two important features signal its true identity. 1. The red or orange color is distinctly a hallmark of Vampyrella. 2. Careful attention to detail, as in the upper photomicrograph, reveals a lack of symmetry and unequal distribution of the pseudopodia. These observations draw attention to the organism as it is floating, and soon it is clear that many pseudopods have been withdrawn, and those that remain are thick, hyaline, few in number, and asymmetrically distributed. In essence, the orange-bodied organism is Vampyrella. Nonetheless, when it has finally settled down and spread itself upon the glass surface of the slide. The appearance of Vampyrella is in many ways surprising. The formerly spherical object is now a loose basket weave of vacuolated ectoplasm and orange endoplasm, extending numerous evanescent phyllos pseudopodia into its surroundings. Here, side by side for comparison, are running videos of the free-floating form and the amoeboid form of the same organism after it has settled down on the slide. Here, the name Vampyrella begins to receive some justification. It looks like a monster from a horror movie, aggressive, fast-moving, and reaching out in all directions with a veritable network of ectoplasmic extensions. However, its true claim to the name Vampyrella remains to be explained. Vampyrella feeds by enzymatically drilling a hole in the cell wall of an algal cell and entering and ingesting the cell's content. Vampyrella may be a vegetarian, but it is a very ferocious one. Ultimately, it is the digested chloroplast pigments which give Vampyrella its color.